completing the square. Essentially what we're going to do today is use a process called completing the square to convert from standard form to vertex form for the purpose of graphing quadratic equations. In order to understand completing the square, first you have to know how perfect squares work. So for each of the examples below, what we are going to do is multiply the binomial to end up with a perfect square trinomial. So remember what it means to square something. When you square something, it means that you multiply it by itself. So here if we have x plus 3 squared, what this really means is x plus 3 times x plus 3. From Algebra 1, you'll remember how to multiply binomials, and a lot of you probably learned the acronym FOIL, first, outer, inner, last. That's exactly the method you're going to use here in order to multiply these binomials together. So first, we would start by multiplying x times x, which is x squared. Then the outside terms will multiply x times 3, which is 3x. Then we'll multiply the inner terms. 3 times x, again, is 3x. And finally, we'll multiply the last two terms. 3 times 3 is 9. Once you're done multiplying, you're just going to add like terms together. So x's go with x's, so the 3 x's in the middle are going to be combined. So my final answer, I'll bring down the x squared, and I'm going to combine 3x plus 3x to get 6x, and then bring down the plus 9. So final answer here is x squared plus 6x plus 9. Take a few minutes to do the same thing on the next two examples. You can pause the video now, and whenever you're ready to check your work, press play. So again here, x minus 4 squared just means x minus 4 times x minus 4. If we multiply this out, we would start with the first two terms. X times x is x squared. Then we would move on to the outside terms. X times negative 4 is negative 4x. Moving to the inside terms, we have negative 4 times x, which again is negative 4x. And last, we have negative 4 times negative 4, which is a positive 16. Now that we're done multiplying, we'll combine like terms in the middle, and we end up with a product of x squared minus 8x plus 16. Okay, we're going to do the same thing for the third example. Again, here we are squaring x minus 2, which means we're just going to multiply x minus 2 times x minus 2. In order to multiply this out, we'll start by multiplying the first two terms. X times x is x squared. Then we'll multiply the outside two terms. X times negative 2 is negative 2x. After that, we'll multiply the inner two terms. Negative 2 times x is negative 2x. And last, we'll multiply negative 2 times negative 2, which is a positive 4. Once we've finished multiplying, you're simply going to combine like terms in the middle. So our final answer is x squared minus 4x plus 4. something that you probably did in Algebra 1. What we're going to be looking at today is actually recognizing the pattern with perfect squares so that we can do something called completing the square. So let me change colors here. What I want to look at is the relationship between this original perfect square and the perfect square trinomial. So specifically looking at these numbers here that I'm underlining. -4, -8, +16. -2, -4x, +4. So looking for patterns and trying to recognize this, what you should notice is 3 times 2 is 6, and 3 squared is 9. For the second one, the same pattern is evident here. We started off with a -4 in our perfect square. Well, -4 times 2 gives us -8 down here in the middle. And -4 squared, -4 times -4, gives us +16. Same thing is true with this last perfect square. We have a -2 inside of our perfect square. Well, -2 times 2 is -4, which is our middle term. And -2 squared is a +4. That's our last term. So what we see here, the pattern, if you want to find a perfect square, is square, double, square. Obviously, we started with x. If we square it, we're going to end with x squared. Backwards like that. I need to square this value. 12 squared is 144. Okay. Now moving one step further. This is the same thing as the previous problems, but it's written in a different way. What we're trying to do here is fill in the blank. We're trying to find the missing value of c that would turn this expression into a perfect square. So remember, square, double, square. Square, double, square. We're trying to turn this thing into a perfect square. Fill in the parentheses here first. What number do you square to get x squared? Well, duh, that's just going to be an x. All right, now this part, what number do you double to get 8? That would be a 4. So my perfect square is x plus 4 squared. Now fill in this last value for c. Square, double, square. 4 squared is 16. So the value of c that's missing is a 16. Okay, it's the same idea as what we saw in the previous slide where you're filling in the blanks. You're filling in the blank to complete the perfect square and to find that missing value for c. All right, let's try the second one. Here we have a trinomial. We know the pattern is square, double, square. First, we're going to turn this thing into a perfect square. So we're going to start with an x because x squared is x squared. And then you have to ask yourself, what number do you double to get -32? That would be a -16. Now, this is my perfect square, but I still have a missing number up here. Remember, it's square, double, square. So we're going to square the -16. Well, -16 squared is 256. So that is my missing value. All right, we're going to continue going. The next one, it's the same idea, square, double, square. We want the perfect square. So we would start with x, because x squared is x squared. And then you want to ask yourself, what number do you double to get a negative 9? That would be negative 4.5. And last, square that. Negative 4.5 squared is 20.25. So the pattern stays the same even when you're dealing with decimals. Okay, moving right along. The second row, this is where it gets a little bit tricky. So far, the pattern is very simple. Square, double, square. Figure out what you double to get the middle term, and then square that value to get the third term. It's really, really easy to do whenever your coefficient in the front is just a 1. So when you have a plain old x squared, it's very simple. What makes this next example more difficult is we're not working with a regular x squared. Here we have 5x squared. So what we're going to do right off the bat is we're actually going to divide this thing by 5. Now, dividing by 5, I don't need that 5 to disappear. I can't just make it go away. What I'm going to do is I'm going to write it on the outside. This is called factoring out 5. You're factoring out the greatest common factor. These are both divisible by 5. I put the 5 on the outside. Now, what I'm left with, if I divide by 5, then I'm going to have a regular old x squared here, and negative 40 divided by 5 is negative 8x. Okay? Now, kind of ignoring the 5 on the outside for right now, look at the parentheses. This is exactly the same thing that we were just doing. You're going to complete the square. We want to turn this thing right here into a perfect square. So remember the pattern: square, double, square. So in my parentheses, I'm going to have to start with an x, because x squared is x squared. And now for the rest of this, I need to know what number do I double to get negative 8. That would be a negative 4. And if I square negative 4, I get a positive 16. Now, the only difference is I haven't worked my way back up to the original row. Remember, in that first step, I divided by 5. So what I want to do here is I want to multiply 5 times 16. So that missing value from the first row, 5 times 16, is 80. So the number that I was missing in the beginning is an 80. And your perfect square would look like this. Remember that 5 does not disappear. It just stays out in the very front. So when you divide it by 5, it just camps out in the front. All right, the next example, we're going to do the same thing. I want you to see it again. Here you have a 4x squared. Well, that makes things a little bit more complicated. So what we want to do here is just divide by 4. The 4 doesn't disappear, it's just going to go out to the very front. And if you divide these things by 4, 4 divided by 4 is 1, so here I just have 1x squared. Negative 8 divided by 4 is negative 2x. And then I'm trying to find the fill in the blank part right here. I'm trying to find that missing value. So I come down one step further, and I want to turn this thing into a perfect square. So remember the pattern: square, double, square. If I fill in my parentheses, I would start with an x, because x squared is x squared. And then I'm asking myself, what number do you double to get a negative 2? That would be a negative 1. And then if I square the negative 1, I end up with positive 1. But this is not the first row. I've got to go back one more step. So remember, I had divided by 4 in the beginning. I need to put this back together. 4 times 1 is 4. That missing number from the beginning is just a positive 4. All right, one more example seeing that. So here we have negative 2x squared minus 12x plus c. We're trying to find the missing value of c that would turn this thing into a perfect square. Well, it's difficult to do with a negative 2x squared. So right off the bat, I'm going to factor out a negative 2. So essentially here I'm going to divide by negative 2 and stick it out in the front. So if I'm dividing these by negative 2, that'll be x squared plus 6x. And I need to find that missing value so that I can take this part and turn it into a perfect square. So negative 2 just hangs out front, and I want to make this thing a perfect square. So clearly we need to start with x because x squared gives us x squared. And then I'm asking here, what number do I double to end up with a 6? That would be a 3. Because 3 times 2 is 6. And then if we square that, we get a positive 9. The only difference here is I can't stop with the positive 9. I've got to take it one more step up here. Remember, I divided by negative 2. So now I need to multiply that negative 2 back in there. So negative 2 times 9 is negative 18. Learn about completing the square is so that we can graph quadratic functions. So in this case, you have y equals x squared plus 2x minus 24. And actually, let's mark off that 4. Otherwise, this graph is not going to end up fitting on here. Let's have y equals x squared plus 2x minus 2. This is our equation. This is written in standard form. Remember, standard form looks like this: a x squared plus bx plus c. And what we learned in the last class, we learned about vertex form, which is a x minus h squared plus k. What we want to do is take the equation out of standard form and change it into vertex form because we know how to graph using vertex form. So in order to get from standard form to vertex form, what we're going to do is complete the square. And here's what this process is going to look like. So we're going to do y equals, and I'm going to put up some parentheses here. I'm going to leave those first two terms alone, x squared plus 2x. But I'm going to push the minus 2 to the outside. So I haven't actually changed anything. The x squared is still in our equation. The 2x is still in our equation. The minus 2 is still in our equation. This is identical to what it was before. I've just put up some parentheses because what we're going to do is we're going to take this section in parentheses and we're going to convert it into a perfect square. This is just like what you were doing on the previous slides. We're going to find the missing values. So looking at what I've underlined here in red, if I'm going to change this part into a perfect square, I would start with x because it's square, double, square. And x squared is x squared. All right, then I need to ask myself, what do I double to end up with a 2? Well, that would just be a 1 because 1 times 2 is 2. And then if I square the 1, 1 squared is 1. Now here we have an issue because originally I had the same equation. X squared is the same, 2x is the same, the minus 2 is the same. But adding this plus 1 into my equation just changed my equation. So what I need to do is balance it out. If I add 1 here, I need to take away 1 on the outside because 1 minus 1 is 0, so it keeps my equation balanced. Now, when I do that, I can combine these terms. Negative 2 minus 1 is negative 3. Now, this equation, I know how to graph. X plus 1, I know goes to the left 1. And the minus 3 shifts our graph down 3. So when I graph this, I would go to the left 1 and down 3. And then remember the pattern for a quadratic function. From the vertex, you go over 1, up 1. Back to the vertex, you go over 2, up 4. Back to the vertex, over 3, up 9. And a mirror image on the left side. From your vertex, over 1, up 1. From your vertex, over 2, up 4. And from your vertex, over 3, up 9. Ooh, it's super hard to draw a parabola with the computer. What I want to do is take this equation and change it into vertex form. So I'm going to start by pushing the 63 to the outside. Leave yourself some space and put the 63 on the outside. Okay, now what I'm doing is finding the missing value of C, just like we had practiced before. We want to turn this into a perfect square. Okay, so remember the pattern is square, double, square. So to change this into a perfect square, I would start with x. And then what do I double to get negative 16? That would be a negative 8. And then negative 8 squared is a positive 64. But I can't just go around adding 64 to my equation. That changes the value of the original function. So to balance it out, if I add 64 here, then I'm going to have to subtract 64 on the outside. 64 minus 64 balances things out. So here I have 63 minus 64, which is negative 1. This function right here is the exact same as the original equation. It's just written in vertex form so that we can graph it. All right, so if we graph this, x minus 8 squared is going to shift the vertex to the right 8. And the minus 1 is going to shift our vertex down 1. So to the right 8 and down 1. That's our vertex. Here we're just going to be following the same pattern as the parent function. So I'm going to go over 1, up 1. And over 2, up 4. A little bit off the graph, that's okay. Same thing, mirror image on the left side. Over 1, up 1. And over 2, up 4. Complicated because we have the 5x squared. So let's walk through a couple of these problems where you have to take care of that coefficient in front of x squared. All right, the first step is going to stay the same. All we're going to do is bump that 15 to the outside. So I've got 5x squared plus 20x. And then I've got the 15 on the outside. All right, from here, we practiced some of these before. You can't complete the square if you have a coefficient attached to x squared. So what we're going to do is divide by 5, and we'll just put that 5, it'll remain on the outside. So if I divide both terms by 5, that's going to be x squared plus 4x. And I've still got that 15 back here at the very end. Okay, the part in the parentheses, we want to take this and turn it into a perfect square. Still have that 5 out there. It's just the part in the parentheses. This is where we want to convert it into a perfect square. So remember the pattern: square, double, square. If I fill inside the perfect square, I would have to start with x, because x squared is x squared. And then I need to know, what number do I double to end up with 4? Well, that would be a 2. 2 times 2 is 4. And then if I square the 2, I get a 4 here as well. Now the difference is, this isn't just a 4. Remember, we have that 5 on the outside? This is really 5 times 4. And 5 times 4 is 20. If I go back up one more step to the original equation, this is 20. And if I add 20 on the inside, I have to subtract 20 on the outside. So just bringing it on down. 15 minus 20 is negative 5. All right, now let's practice graphing this. X plus 2 is going to shift the vertex to the left 2. And the minus 5 is going to shift your graph down 5. So if I go left 2 and down 5, that puts me here. But remember, we had divided by 5. That 5 comes out to the front there. That's going to stretch our graph out. So instead of going over 1, up 1, I'm going to have to go over 1, up 5. And instead of going over 2, up 4, I need to multiply by 5, so I'd be going over 2, up 20. Now that doesn't fit on our graph, so we're going to leave it with these 3 points. Excuse my drawing. We'd get something that looks kind of like that. We want to graph this function. Right now it's written in standard form. We need to convert it to vertex form. So the very first step, put up your parentheses. You're going to kick the minus 21 to the outside. Everything else stays in place. We have negative x squared minus 10x. Now, here we have negative x squared. We don't want negative x squared. We want a positive x squared. So we're going to divide by negative 1, or factor out a negative 1. So the negative 1 just goes to the front. And if I divide this by negative 1, that would give me a positive x squared. If I divide negative 10 by negative 1, that gives me a positive 10x. And what we want to do with this is we want to take it and we want to turn that part in parentheses into a perfect square. So it's all about that pattern: square, double, square. So in my parentheses, my perfect square, I would start with x, and then what number do I double to get a 10? 5. And if I square the 5, that gives me a positive 25. However, we got to work back up one more step and fill in the missing part above this too. Remember, this isn't just a positive 25. this is -1 times 25. And -1 times 25 is -25. So working back to the beginning, if I have a minus 25 that I added to the equation, then I'm going to have to balance it out on the outside by doing the opposite. So if I subtract 25 in here, I'm going to have to add 25 on the outside in order to keep it all balanced. So bringing that down, if I add 25, this is -21 plus 25 is a +4. Okay, we can graph this. X plus 5 is going to shift our graph to the left 5. And the +4 is going to shift our graph up 4. So left 5, up 4. Here we have that -1 out in the front. That just tells me that my quadratic function is going to be pointing down. So instead of going over 1, up 1, I'm going to go over 1, down 1. And instead of going over 2, up 4, I'm going to go over 2, down 4. And instead of going over 3, up 9, I'm going to go over 3, down 9. And there's our parabola. Okay, so in this lesson, the purpose of completing the square was to convert from standard form to vertex form so that we can graph our quadratic function.